Hello everyone, today we are going to solve this Calculus 1 problem here, and this was actually a question on my first Calc 1 midterm in my undergrad. So the question is, prove the trigonometric identity, cotangent squared minus cosine squared is equal to cotangent squared times cosine squared. So there are two identities that we should know before starting this question that will help us with answering this question. So first of all, we'll want to know what cotangent theta is. And if you don't know what cotangent theta is, then you could just remember that tan theta is equal to sine theta over cos theta, and that cotangent theta is just 1 over tan, so it will be just this upside down. So cotangent theta will be equal to cosine theta over sine theta. Okay, so this is the first identity that we need for solving this problem. The second thing that we should know is that sine squared theta plus cosine squared theta is equal to 1. So with these two identities in mind, we'll be able to solve this question. So let's prove that the left side here is equal to the right side. So we have the left side is equal to cotangent squared theta minus cosine squared theta. So we can replace cotangent squared theta with cos squared theta over sine squared theta. Because if cotangent is cos over sine, then cotangent squared is cos squared over sine squared. And then of course we also continue with this cosine squared theta here. Now let's make the denominator the same here. So what we can do is multiply this cosine squared theta term by sine squared theta over sine squared theta. So sine squared theta over sine squared theta is equal to what? This is equal to 1. So if you multiply something by 1, you're not changing it. And now we'll have the same denominator here. So we can express this next line as cosine squared theta minus cosine squared theta times sine squared theta, all divided by sine squared theta. Okay, so now let's factor out one of these cosine squared thetas. So we'll have cosine squared theta, and then in brackets we'll have the rest of this numerator, what's left of it after dividing by cosine squared theta. So this first term becomes 1. Because if we multiply this cosine squared theta into the brackets, then we'll have cosine squared theta. And then this will be minus sine squared theta. So if we take a look at this numerator right here, this is the same as the numerator here, because we've just taken out this cosine squared theta. If we multiply this cosine squared theta back in, then we get the same thing as the numerator here. So this is again divided by sine squared theta. Okay, so we're now getting closer to the right side here. Now let's take a look at this term right here, the 1 minus sine squared theta right here. Is there anything we can do with this 1 minus sine squared theta? Well, remember, if we take a look at this identity that we have here, we know that sine squared theta plus cos squared theta is equal to 1. So if we subtract sine squared theta from both sides, then we end up getting here cos squared theta is equal to 1 minus sine squared theta. And we have a 1 minus sine squared theta term here. So let's replace this 1 minus sine squared theta here with cos squared theta, and let's see what we end up getting. So we have cos squared theta on the outside, and now the 1 minus sine squared theta is being replaced with cos squared theta, and that is divided by sine squared theta. So we can write this as cos squared theta, just to make it more obvious, over sine squared theta times cos² theta. And this is something that we saw at the very beginning before we started the question. What is cos² theta over sin² theta? That is just equal to cotangent squared theta. And this is multiplied by cos² theta. And this cotangent squared theta times cos² theta that we have here, this is the right side. So now we have the left side ended up simplifying to cotangent squared theta times cos² theta, which is equal to the right side. So we can say, therefore, left side equals right side. Hopefully this was useful to you. I'd appreciate if you could share this with somebody if you think it might help them, and good luck on your midterms, and I hope to see you in the next video, so take care.